Hello, yes, and welcome to our Objective 6 notes. Now, Objective 6 says I can solve a linear inequality, graph the solutions on a number line, and write the solution in interval notation. We're going to knock out all of those things today. We're going to have a great time doing it too. All right, so we're going to start with graphing on the number line. All right, so we're going to use two symbols when we practice graphing on a number line. One of them is a closed circle. Now, when we see that closed circle, that means that the point is contained in that solution. The point contains a solution, and that means that we're dealing with inequalities like less than or equal to or greater than or equal to. Now, the other symbol we'll use is an open circle, which means that that point does not contain a solution to the inequality, which means it's strictly less than or strictly greater than. So, by using those symbols, by looking at the inequality symbols, remember less than or equal to, greater than or equal to, less than, greater than, we'll be able to plot these values on a number line. So, our first task here is graph the following inequalities on the number line provided. When we do this, I like to have at least two values on our number line. So, if our first one here, letter A, says x is greater than -2, well, if x is greater than -2, that's any value larger than -2. So I'm going to plot -2, obviously, and like I said, I like to have two values, so I'm going to go ahead and put 0 there also. So, first question, open or closed circle? Well, since this is strictly greater than, x is strictly greater than -2, that means -2 is not a solution, which means we'll use an open circle, place it right above -2, and greater than means that we are going to the right. And boom, that's what our inequality graphed on this number line would look like. Looking at letter B, x is less than or equal to 5. So I obviously need to plot 5 on my number line. I'm also going to plot 0, just because 0 is a nice number. You don't have to plot 0. I'm not going to take off points if you don't plot 0. I just think it's helpful. So x is less than or equal to 5. Now if it's less than or equal to, that means that point contains a solution, which means we're going to use a closed circle. So we'll use that closed circle. Since it's less than or equal to, we'll be going to the left of it, and there we go, and we'll go all the way down to infinity. That's what that arrow shows. That arrow shows that it's continuing all the way down to -infinity. Looking at letter C, x is greater than or equal to -18. All right, well, if x is greater than or equal to -18, obviously I need to plot that -18. And my other point could be 0. 0, of course, is going to be to the right of that value. Now, x is greater than or equal to, open or closed circle. Since it's greater than or equal to, closed circle. And since it's greater than or equal to, we will be going to the right with our arrow there. All right, let's look at letter D now. X is less than -9. If x is less than -9, I obviously need to plot -9. I'll also go ahead and plot 0. Now 0 will be to the right of -9, since 0 is greater than -9. But x is less than -9. So first question, open or closed circle. Definitely going to need that open circle since it's strictly less than. Now since it's less than -9, we'll be going to the left because those are all the values less than -9. Looking at letter E, -12 is less than x, and x is less than 3. So here's one. This is what's called a compound inequality. We have multiple inequality statements here. So I'm going to plot both -12 and 3. Now, I'm going to have to put open or closed circles above both -12 and 3. -12 is less than x. Well, if -12 is less than x, that means I'm going to have an open circle. Oh, sorry, -12 is less than x. Yes, perfect. Now x is also less than 3. Since we have that strictly less than again, we'll have that open circle there. Now x is between -12 and 3, which means my values, I'm going to draw that line that connects those open circles like so. And this shows me that -12 is less than x, -12 is the lowest it can be, and x is less than 3. 3 is the highest it can be. All right, last one we'll do together here. F, 4 is greater than x. Okay, well this is a weird way to write that. We're actually going to go ahead and put this in a more standard form here with our variable first. In order to do that, I'd have to flip the inequality. So it'd be x is less than 4. That's going to make a little more sense. You could always say 4 is greater than x. Like, that makes sense. Like, it's not wrong. But that's more difficult to visualize. That's more difficult to comprehend if we're looking at this inequality. Rather than x is less than 4, which is very straightforward. X has to be smaller than 4. So I'm going to plot 4. I'm going to plot 0. And if x is strictly less than 4, open or close circle, definitely got to use that open. And since it's less than, it's going to be going to the left. All right, let me know if you have any questions. Otherwise, why don't you go ahead and try G, H, and J on your own, and then we'll check those together. All right, let's check how we did here. So first one for letter G, 6 is less than or equal to x, and x is less than 17. So the values I need to plot here are obviously 6 and 17. When 6 is less than or equal to x, well, less than or equal to means closed circle, and then strictly less than 17, so that'll be an open circle. And x is between 6 and 17, so I'm going to connect those dots like so, and that's letter G. H, 8 is less than or equal to x. This is another one of those, like letter F, where we're going to rearrange it here. We're going to put that variable first, so it'll be x is greater than or equal to 8. Remember, when we do that, we got to flip that sign. So if x is greater than or equal to 8, I'm going to plot 8, I'm going to plot 0, greater than or equal to, so since 8 is contained in that solution set, I'm going to go ahead and use the closed circle, and since it's greater than, it's going to be going to the right. There we go, there's letter H. And last one, J, -3 is less than or equal to x, which is less than or equal to 9. So I'll plot -3, I'll go ahead and plot 9, and if it's less than or equal to x, means closed circle, x is less than or equal to 9, again closed circle, x is in the middle of those values, so we're going to go just like that. Alright, so now what we're going to do, instead of being given the inequality and graphing on a number line, we're going to flip that process. If we're given the number line, can we state the inequality? So looking at letter A here, it looks like I have a closed circle at -6, and then it goes to the right. So when we do this, we're always going to put our variable first. So we'll say x, and it can really be any variable. We're just going to assume it's x. All right, now if it's a closed circle, I know it's either going to be less than or equal to or greater than or equal to. And since this is going to the right, we have all the values greater than or equal to -6. So that means x must be greater than or equal to -6. Looking at letter B here, we have an open circle, so I'll say x, and since we're going to the left, we know that has to be less than. Now what is x less than? That open circle is right over 1, so it must be x is less than 1. And looking at letter C here, we have a couple circles. We have one at -10, we have a closed circle at -10, and then we have an open circle at 0. So x, this is going to have to be a compound one, right? Like up above with J or G. If we have two circles, we know that x is in the middle of them. So I'm going to start with the lowest value, -10. And that must be less than or equal to. How do I know it's equal to? Because of that closed circle. And then I'll say x. And now my highest value is 0 with an open circle. So that must be strictly less than, and then I can put 0 right there. And there's my inequality for C. Why don't you go ahead and try D, E, and F, and then we'll check those together. Raise your hand if you have any questions about translating between number line and inequality. Go ahead and try D, E, and F. Go ahead and pause the video and give those a shot. Alright, let's go ahead and check how we did here. So first, looking at letter D, alright, I can go ahead and place my variable x, and I can tell that it's going to be less than or equal to, right? We're going to the left, we have a closed circle, so got to be less than or equal to, and then that value is -4. So this number line says that x is less than or equal to -4. Looking at letter E, we have -4 again, but this time I can tell it's going to be a compound inequality since we have multiple circles here. So first, I'll say -4, strictly less than x, and then my next value, got the circle of death going on here. My next value would be, let's see, 2, so this is going to be strictly less than or equal to 2. There we go, so -4 is less than x, which is less than or equal to 2. Very nice. Now looking at letter F, we have a -2 value here. This time it's going to be strictly greater than, right? Because we have that open circle and we're going to the right. So x is greater than, and this time -2. Very nice. Raise your hand if you have any questions. I'd be happy to come around and answer them. Otherwise, we're going to move on and we're going to talk now about interval notation. Now, interval notation is the method used of writing the solution set. Just like a number line, it's a little different though because it specifies the interval of our solutions. And there's two notations we'll use, hard brackets and soft brackets. Hard brackets look like this. They're 90-degree angles. We call them hard because they're not soft. They're hard angles here. Now, used when the value is contained within the solution set, which means, again, less than or equal to or greater than or equal to, right? If the value is equal to as well as the less than or greater than, that's when we're using hard brackets. Soft brackets really just look like parentheses. All right? They look like so. And that's used when the value is contained within the value is not contained within the solution set, so strictly less than or strictly greater than. And we always use a soft bracket if it goes for infinity. We will always use a soft bracket there. And that's simply because you can't contain infinity. It will continue going on forever and ever. All right, so let's look at a few examples here. Oh, there we go. So looking at these number lines, we can see, oh yeah, -4, x is greater than -2. That one would go on to infinity, right? Would go all the way up to positive infinity. If I look at D, this one would go all the way to negative infinity. So we're going to have to mark that when we're doing these intervals. So looking at letter A, x is less than 6. All right, so the easiest question to ask here is what's the smallest value x can be? Well, if x is less than 6, the smallest value it could be is negative infinity, right? It would just continue going on that number line forever and ever. Now, what's the largest value it can be? Well, 6, all right? 6 would be the largest value it could be. Now, what brackets do I want to use? Well, I always use a soft bracket with negative infinity. And with 6, since this one is strictly less than, I will use a soft bracket there. So both of these sides will be soft brackets because we have that soft bracket for infinity, negative infinity, and we have the soft bracket for 6. And I always write my interval notation in least to greatest. So my least value it could be is negative infinity. The greatest value it could be is 6. Now this soft bracket tells me it can't actually equal 6, which makes sense, but it can go all the way up to 6. So it could be 5.999999999 forever and ever with those 9s, all right? Let's look at letter B here. X is greater than or equal to 12. So the first question I ask, well, what's the smallest value x could be? If x has to be greater than or equal to 12, the smallest value it could be is 12. All right. What's the largest value it could be? Well, if it's greater than or equal to, it'll continue going in that positive direction forever and ever, all the way to infinity. So what brackets do I use? Infinity always uses a soft bracket. What about for 12? Well, since this is greater than or equal to, I'd use a hard bracket there. Hard bracket 12, comma, infinity soft bracket. So that this interval notation tells me the smallest value it can be is 12. It's allowed to equal 12 with that hard bracket. The largest value it can be is infinity. You'll never actually equal infinity though because infinity just keeps going on. All right, let's look at letter C here. Negative 18 is less than or equal to x. Okay, well if negative 18 is less than or equal to x, that's the same thing as x being greater than or equal to negative 18, right? We like that variable first. That makes it easier, more transparent for us to identify what's going on. If x is greater than or equal to negative 18, what's the smallest value x can be? Well, x has to be greater than or equal to negative 18. So negative 18 is the smallest value it can be. All right. What's the largest value then? Well, if x can be any number larger than negative 18, the largest value it could be would be that infinity, right? It could go on forever. So if x is greater than or equal to negative 18, we're going to use a hard bracket for negative 18 because it's allowed to equal negative 18, and then infinity always receives a soft bracket. Looking at letter D now. Negative 3 is less than x, and x is less than or equal to 7. So this is one where we have an interval that's contained on both sides, right? We're not going to have infinity in our answer here. What's the smallest value x can be? Negative 3. What's the largest value it can be? 7. Now let's talk about our brackets here. Negative 3 is strictly less than x, so x has to be greater than negative 3, but it can't equal negative 3. Which bracket communicates that? A soft bracket. Now x also has to be less than or equal to 7. It can equal 7. Which bracket communicates that? A hard bracket. So my interval notation here would be soft bracket negative 3, comma 7 hard bracket. And that tells me that x is between negative 3 and 7. It can't equal negative 3, but it can equal 7. If you have any questions, please raise your hand. Interval notation is probably new. It's probably something we're not quite used to. I'd be happy to answer any questions. Otherwise, why don't you go ahead and pause the video, try E, F, G, and H. Go ahead and pause the video and give those a shot, and then we'll check those together. All right, let's check how we did here. So if x is greater than 149, well, what's the smallest value x could be? 149. What's the largest value it could be if it's greater than? Infinity. Now, since this is strictly greater than, we'd have a soft bracket. Infinity always has a soft bracket, so there you go. There's my interval notation for letter E. Letter F, hopefully we caught, let's put this variable first. So x less than or equal to negative 68. If x is less than or equal to negative 68, what's the smallest value it can be? Well, since it's less than, it'd be going all the way to negative infinity. What's the largest value it could be? Negative 68. Now, is it allowed to equal negative 68? Yes, since it's less than or equal to. Infinity, of course, always has that soft bracket. So we'd have soft bracket, negative infinity, comma negative 68, hard bracket for letter F. Very nice. Now, G is an interval that's contained on both sides, right? So the lowest it can be is 11. The highest it can be is 25. Is that allowed to equal 11? Yes, since 11 is less than or equal to x. So that'll be a hard bracket. Same with 25, right? X is less than or equal to 25. So we'll have a hard bracket there. And that's G. Looking at letter H, 0 is less than or equal to x, which is less than 15. So another contained interval, 0 and 15 here. 0 is less than or equal to x, which means we'll have a hard bracket there. However, x is strictly less than 15. It can't equal 15. It can just go all the way up to it. So we'd have a soft bracket there. And that's some interval notation given an inequality. Now let's do the same thing at a number from a number line. I actually think this is a little bit easier because we can really see visually what's going on. So looking at letter A, we can see that we're going to go from negative 6, but we're not ever going to equal negative 6. That's what that open circle communicates. And that's going to go all the way up to positive infinity. So in interval notation, I'd have a soft bracket. That's what that open circle means. Negative 6. Comma, what's the largest value? Well, this will go all the way to infinity. Infinity always has a soft bracket. There you go. There's letter A. Looking at letter B, interval notation, we want our lowest value first, which means this number line we show negative 2 all the way to the left now. So we're going to continue that all the way to negative infinity. What's the highest value we go to? Negative 2. Hard or soft bracket for negative 2 here? Well, since this is a closed circle, that means it can equal negative 2, which means we're going to have a hard bracket right there. Looking at letter C, this one's going to be contained on both sides, right? It's between negative 8 and negative 6. So I'll have negative 8 and negative 6. Let's talk about brackets here. Negative 8 is a closed circle. Closed circle means greater than or equal to, so we'll have a hard bracket there. Negative 6, however, is an open circle. Open circle means it can't equal negative 6, so we'll have a hard bracket there. All right, why don't you go ahead and try D, E, and F. Feel free to pause the video now, give that a shot, and then we'll check those together. Go ahead and try D, E, and F. Go ahead and pause the video. All right, let's check letter D here. So D, we can see that this one's going to go all the way to negative infinity, since that arrow is going left. All right, now the highest value it can go to is 3, but that open circle means it can't equal 3, so we're going to have a soft bracket there. Soft bracket, negative infinity, comma 3 soft bracket is our solution for D, or is our interval notation for D. Looking at letter E, all right, so this value looks to be negative 3, and the highest value looks to be 8. We got closed circles on both. Closed circle communicates directly to that hard bracket. So there we go. Looking at letter F, we have negative 5 as our lowest value. So we'll have negative 5 there. And then that'll go all the way to positive infinity. So negative 5, got a closed circle on that. So that'll be a hard bracket. infinity there. We got the soft bracket, of course, for infinity. Infinity will always have a soft bracket, remember. Infinity will always have that soft bracket. Now let's move on here. Let's move on. Let's talk about actually solving these linear inequalities. Now that we know how to write our solutions and how to graph on a number line, let's actually solve them. Alright, so when solving linear inequalities, we use the same process as when we're solving linear equations. There's just one additional thing we need to remember. Whenever we're solving this, we have to remember to flip the sign if we multiply or divide by a negative number, alright? If we ever multiply or divide by a negative, we gotta flip that sign. So let's look at our first set here. Looking at letter A, we're going to solve the inequality, graph the solution on the number line, and write our answer in interval notation. We're going to knock out all of those things for letter A. So, first thing, I'm going to solve it just like it was an equation. You can almost write that equal sign right above, right? We're going to treat it just like it's an equation. So what would I do to get x all by itself? Well, first I'd have to subtract 12 from both sides. What's negative 4 minus 12? Negative 16. Which means negative 16 is less than 2x. To get x all by itself, divide by 2. Divide by 2. Negative 16 divided by 2 is negative 8, which is less than x. Now I had a good question that said, yo, do I need to flip the sign here? No. Only if we divide by a negative. We can divide a negative by a positive and not flip it, but if we were to divide by a negative, if this was negative 16 divided by negative 2, then we'd have to flip the sign. Now our solution here has our number first. We prefer to put that variable first, so it would be x is greater than negative 8, and there is our solution. Excellent. Now let's go ahead and graph this on the number line. So on the number line, I'd mark negative 8, and I'd go ahead and mark 0 as well. Since it's strictly greater than, I'll have an open circle. Greater than goes to the right, so it would look like that. And that's what that would look like on a number line. Now let's do interval notation. So let's see, negative 8 is the smallest value it can be. It goes all the way to infinity, so that'll be the largest value it can be. Since we have an open circle, it's strictly greater than, we'll have a soft bracket on negative 8. And then infinity, of course, always has that soft bracket. There we go. All right. Questions? Feel free to raise your hand at any point if you have questions. Happy to come around and help. Let's look at letter B now. First thing I'm going to do is I'm going to, let's just divide by negative 3 here. If I divide both sides by negative 3, notice, dividing by a negative, alarm should be going off in our head. All right, so I'm going to have x minus 3. Originally it was greater than or equal to, but since I divided by that negative, I'm flipping it. Now it needs to be less than or equal to. Now 57 divided by negative 3 is negative 19. Alright, everyone understand why we flipped that there? Since we divided by that negative, we have to flip that sign to account for it. Alright, so now to get x all by itself, I just need to add 3 to both sides. I'll have x is less than or equal to negative 19 plus 3 is negative 16. So my expression now, x is less than or equal to negative 16. Let's go ahead and plot that on our number line. So if I put 0 there, I can put negative 16 here. I'm going to put my closed circle above negative 16, right, since it's less than or equal to. Since it's less than, we're going this way to the left. There we go. All right, now interval notation. What's the smallest value x can be? Well, if I look at my number line, I see that it goes all the way to the left. It's going to continue that way all the way to negative infinity. What's the largest value it can be? Negative 16. Hard or soft bracket for negative 16? Hard bracket, because we got that closed circle. It's less than or equal to. We're allowed to equal negative 16. That's what that hard bracket communicates. All right, let's check out letter C now. The negative quantity of m minus 7 minus 2 is greater than or equal to 5 times the quantity 1 plus m. All right, so let's distribute this negative first. So I'm going to have negative m plus 7 once I distribute that negative to both m and negative 7. And then minus 2 greater than or equal to 5 times 1 plus m. Let's distribute that 5. So I'll have 5 times 1 is 5. 5 plus times m is 5m. Combine some like terms here. I have negative m plus 7 minus 2 would be positive 5. Greater than or equal to 5 plus 5m. All right. let's see here. I'm going to add m to both sides so I can get my m's on the same side of the inequality here. So I'd have 5 is greater than or equal to 5 plus now 6m, because 5m plus 1m is 6m. And now I got to get my numbers on the other side. So I'll subtract 5, subtract 5. 5 minus 5 is 0. So I have 0 is greater than or equal to 6m. To get m all by itself, I'll just divide by 6, divide by 6. 0 divided by anything is just 0. So that tells me that 0 is greater than or equal to m. Now that puts our number first. Remember, we don't really like that. So let's switch this around to our variables first. M then must be less than or equal to 0. And there's something we can plot, right? Let's graph that on the number line. There's my solution. Let's do all the things we can to it. So m is less than or equal to 0. I'm going to go ahead and plot 0. Like I said, I like to plot another value, so here's 3. Alright, if m is less than or equal to 0, I'm going to have that closed circle above 0. And then since it's less than or equal to, I'm going to be going to the left. Alright, now what would that look like in interval notation? Well, negative infinity is going to be the smallest value I can have since we're going to the left. The largest value I have is 0. Negative infinity always has a soft bracket. 0 in this case is going to have a hard bracket because m is less than or equal to 0. My 0 is contained in my solution set. M is allowed to equal 0. Alright, and that's letter C. If I look at letter D, here's something a little unique. This is actually a compound inequality. Now we solve a compound inequality exactly the same, except instead of only having one inequality and two sides, now we have two inequalities, which means that I have to do the same to all three inequalities that we have. So we're still going to try to isolate x all by itself here. So let's subtract 7, and we need to do that from all three expressions here. So negative 5 minus 7 is negative 12, which is less than or equal to 6x, which is less than or equal to, I also need 43 minus 7, which would be 36. Now to get x all by itself, divide by 6, divide by 6, divide by 6. I got to do that to all three values, okay? So negative 12 divided by 6 is negative 2. 6x divided by 6 would just be x. And 36 divided by 6 is 6. So I have negative 2 is less than or equal to x, which is less than or equal to 6. So let's talk about how we can graph that on our number line. That's it. That's our inequality. Let's put it on a number line. So we got negative 2, we got 6 right there. They're both less than or equal to, so that means we're going to use closed circles, and then x is the value in the middle of them. So we're just going to connect those closed circles like so. In interval notation, negative 2 is the smallest value it can reach, 6 is the largest value it can reach. We're going to put hard brackets on both of those since x is less than or equal to both of those, all right? Questions? Feel free to raise your hand if you have any questions. Otherwise, why don't you go ahead and try letters E and F, and we'll check those together. All right, let's check on letter E and F here. So looking at letter E, first thing I'm going to do, I'm going to distribute this negative 3 into everything. So a negative 6r plus 15 is less than negative r plus 30. All right, so now we get these r's on the same side, so let's add 6r to both sides. Add 6r. When I do that, I get 15 is less than negative r plus 6r would be 5r plus 30. I can subtract 30 from both sides because I got to get my numbers on the other side. So negative 15 is less than 5r. Divide both sides by 5 to get r all by itself. Tells me that negative 3 is less than r. Now I don't really like that. I want that variable first. If I gotta do that, I flip my sign. R is greater than negative 3. Fantastic. All right, so now that we have that, let's plot this on our number line. We got negative 3 here. You put 0 there. Open or close circle. Well, since it's strictly greater than, we'll have an open circle. Greater than goes to the right. There we go. So that number line now communicates that r is greater than negative 3. Interval notation here. Yes. Well, the smallest value we can have is negative 3. It goes to the right all the way to infinity. Open circle above the negative 3 tells me we're going to have a soft bracket for -3, and then infinity, of course, always has a soft bracket. So my interval notation here would be soft bracket -3, comma, infinity, again with this soft bracket. And that's letter E. Now let's check letter F. Letter F, I'd start by distributing this negative into everything. When I do that, I'd have the opposite of -4p, which would become positive 4p, the opposite of -3, which is positive 3, less than 7p plus 3. So I'm going to start here by subtracting 7p from both sides, subtract 7p. So I'd have -3p plus 3 is less than 3. And then I need to get the numbers on the other side of the inequality, so subtract 3, I have -3p is less than 3 minus 3 is just 0. I can divide by -3 to get p all by itself. 0 divided by anything is just 0. I'm going to bring this up top here. When I do that, I now have p is greater than 0. Now notice, originally it was less than, but what did I do? I divided by a negative, so I got to flip that sign. Now it's p is greater than 0. So I'll plot 0 and I'll plot 5, just another number to have there. If p is greater than 0 is my solution set, that means I'm going to have an open circle above 0. Greater than would be going to the right. There we go, just like that. Interval notation would tell me that my smallest value is 0. My largest value, since I'm going to the right, hopefully we wrote infinity. And then soft bracket for 0, soft bracket for infinity, soft bracket for 0 because it's strictly greater, and then infinity, of course, always has that soft bracket. How do we do? Raise your hand if you have any questions. Otherwise, why don't you go ahead and pause the video and try G and H, all right? So go ahead and pause it, try G and H, and then we'll check those together. All right. Let's go ahead and check letter G here. So looking at letter G, I think I'd start by distributing everything that we need to here. So I'd distribute that 3, and I'd also distribute this -7. So I'd have -2n. 3 times -4 would be -12, so this will give me -12n. And then 3 times 6 is 18. And that's going to be greater than or equal to, -7 times 1 is -7. And -7 times 2n would be -14. Alright, so let's combine our like terms here. -2n plus -12n is -14n plus 18. And then we have greater than or equal to -7 minus 14n. Now when I add 14n to both sides to get those, wait a minute, -14n plus 14n is 0. So this will be 0 plus 18 is greater than or equal to -7 plus 0. That's 18 is greater than or equal to -7. My variable's gone. Interesting. What else have we worked with where our variable has gone, right? This is where we get into infinite solutions or no solutions. Now that vocabulary doesn't really work well here since we're dealing with inequalities. However, it's the same idea. Is this a true statement or a false statement? Is 18 greater than or equal to -7? Yeah, it is. This is true, which means that n can be any value, and we're going to get this true statement. Well, if n can be any value, that means on a number line, it can be anything from -infinity to +infinity. And that tells us our interval notation also. It can be anything from -infinity to +infinity. So that would be our solution for G. All real numbers from -infinity to +infinity. And that's G. Let's talk about letter H now. Letter H, looking at this, some people probably distributed that 5, but I see that -120 is divisible by 5, so I'm actually going to do that division right now. Now -120 divided by 5, that's a tough one. Let's check that on the calculator here. So -120 divided by 5 equals -24. So -24 is less than or equal to, and now I'm just left with what's in the parentheses, -5k plus 1. To get k all by itself, I'd subtract 1 from both sides. I get -25 is less than or equal to -5k. I can divide by -5, divide by -5. Oh, I divided by a negative. What's that mean? Got to flip that sign. -25 divided by -5 is +5. And what was less than or equal to is now greater than or equal to k. However, notice here, that puts my number before my variable. We don't like that. So let's go ahead and rewrite it. K, when I do this, I got to flip that sign again. Less than or equal to 5. On my number line, I'm going to plot 0, going to plot 5. All right, so if my inequality here tells me k is less than or equal to 5, I'll have a closed circle above 5. Less than or equal to would be going to the left. In interval notation, what's the smallest value I can have? Well, since it's going to the left, it'd go all the way to -infinity. What's the largest value I can have? 5. Is it allowed to equal 5? Yes. So that means we're going to have that hard bracket there. All right, that's G and H. Raise your hand if you have any questions, especially on G. I'd be happy to explain that farther. Otherwise, why don't you finish strong? Go ahead and knock out J and K, and then I'll check in with you here. Go ahead and pause the video, try J and K, and then we'll do it together. All right, looking at letter J, we have this compound inequality, right? Which means whatever we do to one side, we're going to have to do to all the others. So let's start by distributing this 3. When we put that in there, we'll have -3 plus x is less than or equal to 3x plus 15, which is less than 45 plus x. All right, so I'm going to start by getting all my x's in this center inequality. That's always a goal if this is the case. So we'll subtract x from all 3 expressions here. When I do that, I'll have -3 is less than or equal to now 2x plus 15, which is less than now 45. All right, so we have that x in the middle. Excellent. Now let's get it all by itself. Subtract 15. I'm going to do that from both sides. And by both sides, I really mean all 3 sides here. So -3 minus 15 is -18, which is now less than or equal to 2x, which is less than 45 minus 15 is 30. To get x all by itself, divide by 2, divide by 2, divide by 2, which tells me -9 is going to be less than x, which is going to be less than 15. Less than or equal to. Sorry, I can't forget about that. Oh, wait, no, I'm writing this wrong now. This is where the less than or equal to is. -9 less than or equal to x, which is less than 15. So on my number line, I'll plot -9 and I'll plot 15. Going to have a closed circle above -9 since we're less than or equal to. Going to have an open circle above 15. And then we'll connect our dots there. X is everything between -9 and 15. It's allowed to equal -9, but it can't equal 15. Interval notation here, hard bracket -9, 15 with that soft bracket. I'm going to try to finish this up real quick. Looking at letter K, got to distribute everything here. So we're going to have, oh goodness, check out this distributing that we got to do. 3 times 2 is 6. 3 times -x is -3x. 4 times x is 4x. 4 times 5 is 20. -2 times x is -2x. And -2 times 8 is -16. Combine some like terms. I have -3x plus 4x. That will give me 1x. I have 6 plus 20. That will give me 26. Less than or equal to -2x minus 16. Let's see. Let's add 2x here. Add 2x. So we'll have 3x plus 26. It's less than or equal to -16. If I subtract 26, subtract 26. So I now have, let's see, this would be 3x. -16 minus 26 would be -42. I can divide by 3, divide by 3. I find that x is less than or equal to -42 divided by 3 is -14. So I have 0. I have -14 would go right here. Since x is less than or equal to that, I'll have that closed circle. I'm going to the left since it's less than or equal to. Interval notation, oh goodness. Let's see, we have that soft bracket, -infinity. We have -14 with the hard bracket. There we go. All right, and I am all done. That was a lot of notes today. Well done, guys. Mr. Carter signing off.